Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In our previous two classes, we learned about what is a graph and how to represent graph using adjacency matrix and adjacency list. In this class, we will see graph as ADT. Overview of the session. In this session, we see definition of graph and graph representation using adjacency matrix and adjacency lists, and finally we see C program creates an undirected graph using an adjacency matrix representation. Outcome of this lecture: at the end of this lecture, you all are construct adjacency matrices for a given graph. You will write, compile and run similar C program to create and manipulate undirected graphs. So what is graph? So graph is a collection of vertices and edges. If you want to detailed explanation about graph, then refer our previous videos. Here, so vertices are fundamental units of the graph. Edges are used to connect these vertices. So mathematical representation of graph is G equals to V comma E. So V is set of vertices and E is set of edges. There are two ways of representing the graphs in memory. So one is using adjacency matrix, another one is using adjacency list. So this is the adjacency matrix, means you are representing your graph using 2D array, where each cell I comma j indicates if there is an edge between vertex I and vertex j. And similarly, adjacent list is a collection of lists where each list corresponds to a vertex and contains a list of its adjacent vertices. So now I want to represent this graph as ADT. So how means? So for this I am using adjacency matrix. Now, so what is the size here? Number of vertices are 5. So I will allocate memory for 2D array. So 5 into 5. So it is A, B, C, D, E, A, B, C, D, E. Okay. So next I initialize all the vertices with 0, 0, 0, 0, 0, 0. Okay. Now how I represent an edge from A to B? So A to B means this is the 0 index, 1, 2, 3, 4. Here also same, 0, 1, 2, 3, 4. So now for example, here there is an edge from A to B. So A to B is 0, 1. So here I change this 0, 1 as a 1 here. So this is the 1. And similarly, so there is an edge between A to E. A is 0. So what is E here? E means 4. 0 to 4. Here I mention as a 1. Similarly, from consider this as a 2 and 3. So B to C means 1 to 2. 1 to 2. Here 1 here. So 1 to 3. 1 to 3. Here I mention as a 1. And similarly, coming to C, so 2 to 3. 2 to 3. Here I mention as a 1. For D, for B we have E also. So it is 1. Okay. So D we have only one edge to E. So here I mentioned as a 1. From E we don't have any edge. So all are zeros here. Okay. So let us see C program to define this graph as ADT. Let us see C program. So this is the program to represent graph here. So this is the structure here. struct graph, so number of vertices and adjacency matrix. So this is the function we use to create graph with a given number of vertices. If we give 5 vertices, it creates 5 into 5 2D array and initialize all the edges with 0. Okay, if you observe these for loops, maybe you understand. And next, so this function add edge, I use it to add new edge to the graph. So what it means, here we are taking undirected graph. So if there is a edge between A to B means it is vice versa. That means the edge between B to A also. So here I change the status from 0 to 1 here. This is the function we use to print the graph. Now I represent the same graph in the form of adjacency matrix. So this is the main program. The same graph what we discussed previously, the same graph I represent here. Okay. Now, so before this graph, here I am taking the graph with size 5. So number of vertices equals to 5. So now, so print graph means what it prints? It prints 5 into 5. So 2D matrix. So that means so 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0 means A, B, C, D, E. So this is the diagram already seen in our previous slide. Okay. Now this is the, so when we create a graph, now all these are initialized with zeros. Okay. So now here I am adding edge from 0 to 1 here. Now add edge function will call. So what is the add edge here? 0, 1. So 0, 1 and 1, 0. So these two will be 1 here. So in the place of 0, 1, we write 1 here. Similarly 1, 0 also 1 here. 0, 4. 0, 4 is 1 and 4, 0 is also 1. So 1, 2. 1, 2 is 1 and similarly 2, 1 is also 1. So 1, 3, 1. So 3, 1 is also 1. So 1, 4 is also 1. So 4, 1 is also 1. So 2, 3. So 2, 3 is 1 and 3, 2 is 1. So 3, 4 is 1. So 4, 3 is also 1. Okay. So this is the final representation of graph using adjacency matrix. So let us execute this program. You can find this program link in the description. So this is the output of the program. So before add the edges, so this is the output. If you observe, all the edges are zeros here. After adding these edges, so these are the adjacency matrix. So this is about how we define the graph as ADT. Summary of this session. In this session, we learn the graph ADT. So what is a graph ADT? Is a mathematical and abstract concept used to represent a set of objects. Here the objects are vertices, so connected by edges. And we learn so adding vertices and adding edges and retrieving neighbors. So how we retrieving the neighbors? If the value is 1, then we retrieve that value as neighbors. And adjacency matrix representation, we use adjacency matrix to represent this graph ADT. We use 2D array and each cell I, j indicates whether there is an edge, then I indicate this as a 1. And the size of the matrix is V into V, where V is the number of vertices. I hope you all are understand the graph ADT. If you have any doubts, so place your doubts in the comment section. I will answer all your doubts. Thank you.